Okay, now that we've learned all the forms of linear equations, we are going to have to convert back and forth. And we did a little bit of that when we were doing the standard form in the last lesson. But as a reminder, let's keep in mind what the three different forms are. So we have slope-intercept, and just like it says, it tells us the slope, and it tells us the y-intercept. So y equals mx plus b. That's the first form that we kind of learned. Okay, the next one was point slope. And in that one, we're given a point and a slope. And we can graph from that one, or we can convert it. Y minus y1 equals m times x minus x1. Okay, and then our final one that we learned last class was standard form. Standard form, you can't just graph from it. You either have to change it to another form or you need to plug in values. Okay, but that's ax plus by equals c. Remember, in all of these cases, when you are in the actual form, you have numbers in every place except for the y and the x. Everything else is a number. So in the slope-intercept form, the m and the b, there's an actual number there. In the point-slope form, the y1, the m, and the x1, there'll be a number. And in the standard form, the a, the b, and the c will be actual numbers. Okay, so these are the three forms we talked about and learned about and looked at each one separately. Now we want to put them all together. Okay, and we need to be able to convert between different forms. So let's look at an example. Okay, given that the slope of a line is -3, and it passes through the point 6, 2. Write linear equations in all three forms. Okay, I don't know why it keeps doing that to my F's. I guess it looks like a slanty line. I don't know. All right, so, oh great, now I have a different color. What are you going to do? Let's do this before we even, for those of you that are more yellow thinkers, the conceptual thinkers in the crew, let's graph it first to kind of see what we're dealing with, okay? That's always a good idea for those of you who are more conceptual learners. And so we're going to start. This time we don't have a starting point on the y-intercept. We can put this point, 6, 2. 1, 2, 3, 4, 5, 6, 1, 2. There's my point. And then we have a slope of 3. Oh no, it doesn't have a denominator. What are we going to do? We all know the denominator is 1. So m equals -3 over 1. So that means we can go down 3. Let's be careful. And to the right 1. Be careful of that. Or we could go up 3 and to the left 1. Remember, when you draw this, don't give me some wimpy line. Don't give me some line segment. Give me a line that goes through all 3 and it has arrows in each end. Okay? So that's what our line would look like. We could do a lot of things from there. In this one, we can't really tell the y-intercept because it's way above it, but we can see the slope is -3 over 1. We do have a point. So if we have a point and a slope, that kind of tells us where to start. A point slope, well, let's start with the point slope form. Doesn't matter where we start, but since we're given a point and we're given a slope, that makes the most sense to start at the point slope form. So again, remember it's y minus y1 equals m parenthesis x minus x1. Let's write down in blue what's original to this equation. Or what's going to stay in this equation. The y and the subtraction will, the m, the parenthesis, the x, and the other parenthesis. We have to fill in for the other pieces. Well, from above, we found out our m is -3 over 1. So for our m, whoops, we are not keeping that m in there. Whoops. We're going to put -3 over 1. Now, do I need the 1? I don't really. So I'm just going to leave it as -3. And then, do we have an x1, y1? Well, we do. Our x1 is 6. Here it is up here. I'm just getting it from up there, so I just wrote it in orange. And then our y1 is 2. And that was up here from this point. So I'm putting that there. There we go. Point slope form done. Check. Okay. Now let's see. We need to get it in to slope-intercept form or standard form. Well, I'll tell you, to go from point slope form, the next easiest one, you may not know this, but I'm going to tell you, is slope-intercept form. We just have to do some algebra using the rules of algebra. Okay? So remember, the slope-intercept form is y equals mx plus b. This is what we want. This is what we have. So let's start with what we have. Y minus 2 equals negative 3x minus 6. Well, the first thing I notice is we really don't, if I'm trying to get from here to here, we don't, from here to here, I went backwards. We don't want parentheses. So let's distribute that 3 to take care of those parentheses. Because once you distribute the 3, the parentheses go away. The negative 3, excuse me, be careful. So I have negative 3x. Now be careful, negative 3 times to subtract 6 is going to give you a plus 18 or a positive 18. We didn't do anything yet to the other side. Well, we still aren't in y equals mx plus b, so you need to stop and think, how can I make this look like this? Well, we just need to get that 2 away from that y. Well, if we're moving sides of an equation, that's when we draw our line, and that's when we do opposite operation. What does that plus 2 go under on the other side? Does that plus 2 go under the negative 3x, or does it go under the 18? It has to go under the 18 because it doesn't have an x on it. Okay, so now we have y equals, oh, let's make that y a little closer to the equal sign because there's nothing else over there. So y equals negative 3x plus 20. Does that look like that? Does that look like slope-intercept form? Yes, it does. We're done with slope-intercept form. There we go. We just had to use the algebra that we learned in chapter 1. Okay, then the final form we have to put it in, and we did this last section, is we have to do standard form. Now remember, standard form has all those checks. Standard, look at me, I don't know how to spell. Standard form has a bunch of checklists. So the standard form has to look like ax plus by equals c. And as I'm going through these, maybe think, do I know the checklist, or am I going to make sure I write that down on my cheat sheet? A cannot be negative. No fractions or decimals. And that last one that's kind of weird that people forget all the time, GCF has to equal 1. Okay? Here's our checklist. Okay, well, we needed to get it to look like this, the equation. And remember, this is all the same line that we drew at the beginning. And we'll go back and look at that again. We are currently in this form. This is what our line looks like right now. We are in this form. Well, the first thing I notice is we don't have any fractions or decimals, so I'm checking that off. Makes me feel better. But I do notice that my x is on the wrong side, so we got to do a little solving. We got to move some things around. I'm going to add 3x to both sides. Completely legal move. Why did I do that? Because I want it to look like ax plus by. So now I have 3x plus y, and it has to equal, well, this is gone, so we're equal to 20. Okay, that looks right. We have a x and a y in the right places. We have numbers in the front, so I can check that out. Okay, is a negative? Well, which one's a? The 3. Check it off. GCF of 1. Well, what's the coefficient or the number attached to the y? What's attached to that y? Well, remember, we have an invisible 1 there. We don't have to write it. We usually don't. But if there's an invisible 1 there, the only factor of 1 is 1. And so that's it. GCF is 1. We're done. There it is. We put it in all the 3 forms. These 3 forms, oh, let me put a box around this one, all represent this line. These are different formulas to create that line. Okay, there's always a connection between a graph and an equation. These 3 equations are all exactly the same line. They're just written in different forms. Okay, just want to make sure you see the big picture there. All right, let's do one more example, and then you're going to try a couple on your own for homework, or whatever you want to call it, classwork. Example number 2. This time, we're going to have to go right from the very beginning. I'm going to give you 2 points, and that is it. You have to graph it, you have to write it in 3 different forms. We have to do a whole thing. This took a whole page of my notes. I like to leave spaces, but this took a whole page of notes for me. I'm going to start with graphing it. Again, for some of us, that's not necessary, but for some of us, seeing the graph is really going to help us understand the connection between all these. Okay, so let's graph these 2 points to graph my line. I ask for 3 points when you're graphing, but if I only give you 2 points, you can use those 2 points to graph. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Remember, when we're graphing a point, it's not the same as graphing a slope. We go x and then y. And while I'm at it, I'm going to name these x1, y1, so we already have them labeled. x1, y1. Isn't that exciting? And this is going to be, oh, my pencil's running low. Hopefully I can get through this. x2, y2. Okay? So this is my x1, y1. And then let's do our second group. I'm going to do that in blue. -2, +3. Okay, before I even draw this, I already can tell my slope is going to be positive. Remember, no wimpy lines, arrows on both ends. Make them nice. Make this look like a line that goes on forever. I wonder if I could count the slope. I wonder if I have to figure out the slope. Well, let's see. Oh, this is what happened last time, so let me make sure I know what I'm doing here. Okay, so I don't want to use that color. Let's start at this point, and we're going to go up 1, 2, 3, 4. Okay, well, I have to go up 4, and then to get to that point, I have to go 1, 2, 3, 4, 5, 6, plus 6. It looks like my slope is 4/6, which is 2/3. Now, that's one way to figure out the slope. Or I could do the algebraic way. M equals y1 minus y2 over x1 minus x2. You could use either way here to figure the slope out. Okay, I'm going to fill in what I know. y1 is 7, y2 is 3. x1 is 4, and x2 is -2. Be careful of your negative. So on the top I get 4, on the bottom I get 6, because 2 negatives make a positive. That makes that +6. Oh, and in case I simplified too quickly there, I just divided the numerator and the denominator by 2. That's a legal move, so my slope is 2/3. Did this match the picture? Yep, everything matched. Okay, so there's our slope, 2/3. So now we have our slope. That's what you always need to start with, okay? So we have our slope. I'm going to write this here. And do we have a point? Well, we actually have 2 points. I'm going to actually show you both ways, okay? So we found the slope, so that's number 1. Find slope. Sometimes to find the slope, you just have to look for it. It's written in the problem. Okay? Number 2, almost always put it in point slope form. That's a P. I'm going to do it twice because we have 2 points. Our first point is 4, 7. And our other point is -2, 3. And I want you to see what happens. No matter which one I pick, when I go to the third step, it's going to come out correctly. I think I made this one x1, y1. And I'm going to do this twice, so let's do this first side. And remember, point slope y minus y1 equals m times x minus x1. Okay, so we have y minus 7 equals, slope is over here, 2/3 x minus 4. That is the correct answer, point slope form. Let's go to the other one. Y minus 3, oh, I'm going to name these x1, y1 for this problem, okay? Y minus 3, I don't know what color I was using, equals, again, same slope, same line, x minus -2. I don't like that, so I'm going to rewrite this in a little simpler form. Now, it may not look like it right now, but these two are both the same equation. Okay, they're just using different points. Watch what happens when I convert both of them. You don't have to do both of them. I'm just showing you that you could pick either point. When I go to convert them to slope-intercept. And remember, slope-intercept form is y equals mx plus b. So I'm going to take this one first, and I'm going to start converting it. So y minus 7 equals 2/3 x minus 4. Ooh, I don't like that fraction in there, but I'm going to take care of it. Don't worry. Let's start with just distributing that 2/3, okay? Because I think sometimes clearing the fraction before getting rid of the parentheses can be confusing. Okay? The next step with this is that I want to get rid of those 3's. Well, remember, we can clear the fraction by multiplying both sides by 3. And I'll do all the steps here. And remember, it's 3/1 if you need it to be. So this would be 3y minus 21. That would be 6/3x minus 24/3. So that simplifies down to 3y minus 21 equals 2x minus 8. Okay? Next step, I want to get y by itself. So I'm going to add 21 to both sides because we're trying to get it to y equals mx plus b. Keep in mind where we are. Why am I getting a different answer? Oh, because I'm not looking at it correctly. 3y equals 2x, and 21 minus 8 is 13. Okay? Oh, I wrote 3, not 13. You got to be careful of that. All right, still not done. We've got to divide both sides by 3. When I say both sides, that means everything on both sides. So it's y equals 2/3 x. And I don't want this written as a repetend. That's not an exact answer, so you're going to leave it as an improper fraction. There it is. Okay, that's one time. You don't have to do it twice, but I want to show you, what if I had chosen the other one? What if I chose the other point? What would happen? Okay, let's do that. First step, I want to get rid of the parentheses, so I'm going to distribute. 2/3 x, remember top times top, and 2 has an understood 1 under it, so that's 4/3. Okay? Then I'm going to clear my fraction, I think. Well, it's kind of up to you. What if I didn't want to clear my fraction? What if I just wanted to do this? Well, for me, I got out my calculator and I did that fancy math frac enter enter. And I can get the answer. Shockingly, the answer is 13/3 plus 2/3 x equals y. What does that remind you of? I know, it's the same one. I told you, it doesn't matter which point you pick, you're going to get the same answer. So it's the same equation, it's just written in a different way. Okay, let's go to our final step, and the final thing in this lesson is to take that equation, they're both the same, and put it in standard form. So let's just take the equation, y equals 2/3 x plus 13/3. Don't forget our checklist. ax plus by equals c. A can't be a negative. No fractions or decimals. And GCF has to be 1. Okay? First of all, I see fractions, so I'm going to deal with them. I'm going to multiply everything by 3. Common denominator. So I have 3y, and for those of you who are still unsure of this, put your 1 under this, and we're just distributing it, okay, to everything. So that would be 6/3x, and this would be 39/3. Well, if you simplify those fractions, you actually get 3y equals 6 divided by 3 is 2. That's where I get 2x. And 39 divided by 3 is 13. Okay, fractions are taken care of. Now the x is on the wrong side because remember we need it to look like ax plus by. So I'm going to subtract 2x from each side. All right. What's in front of that 3y? I see people all the time do negative 2x 3y. That's not true. There's an understood plus there. So it's negative 2x plus 3y equals 13. Okay, we're in the right form. ax plus by equals c, but what else is wrong with it? Oh, there's a negative, so I got to divide everything by -1. Everything. This is where the most mistakes can occur. So we have 2x minus 3y equals -13. Check. A is no longer negative. Final thing, GCF. Is there anything that you can divide into 2, 3, and -13 that would give us whole numbers for all of them? And there isn't. Partly because 3 is prime, and so is 13. Oh, and so is 2. They're all prime numbers, so nothing goes into them. Okay? I'm sorry, 2 is not prime. No, 1 in itself. Okay. And then that is my standard form. So there's a lot of work. There's a lot of algebra. There's a lot of chapter 1. There's some chapter 2. So if you're having trouble with this, it's understandable. But please don't just sit there and say, oh, well, I don't understand it. Get some help from me or Mr. B.